Part C.
Like the problems?
Yeah.
Yeah, well that's all we're doing, but whereabouts?
Yeah. Part C number 3.
1, 2, 3. An electron one?
Yeah.
Okay. So I have an electron with a mass. Mass is 9.1 times 10 to the negative 31 kg. Charge, so it's an electron, so it's 1.6 times 10 to the negative 19 coulombs. It's accelerated, so I have a velocity of 4 times 10 to the 6 meters per second. Then enters a uniform magnetic field, that's a B, 5 times 10 to the negative 3 Tesla. What is the radius of the circular path that follows? Okay, so again, this section, we basically are using 2 primary formulas. The first one is this centripetal force one, mv squared over r. And the second one is force equals BeV or BQV, in which you get the amount of force from a magnetic field in which you have the amount of Teslas, the charge of the particle, and the velocity at which it's moving at. So I want to get R in this here. So to get my R is equal to mv squared, okay, over BeV. All right, so that squared and that V cancel out. So I'm left with M times V over BE. So to get my radius, I have 9.1 times 10 to the negative 31. Velocity is 4 times 10 to the 6. My B is 5 times 10 to the negative 3. And my charge is 1.6 times 10 to the negative 19. Let's get our radius. You understand the setup, Thielen?
Yeah.
So 0.455 centimeters. Okay. They did it in millimeters, so I times it by 10 one more time. Okay, so far? Now it says, sorry, go ahead.
I just said thank you.
Okay, no worries. And now is where it gets a little bit more complicated. So this is that other one I told you to add to your sheet, and that is what is the potential difference? Was the electron through what potential difference was the electron accelerated? Okay, so, well, I don't even need to do this. Let's do it like this. Work is equal to charge times my voltage. So I want my voltage, which is, oops. Work over charge. So now I got to figure out how to get work. Well, work is the same as kinetic energy. So I can go 1/2 mv squared divided by my charge, and that will give me my potential difference. Okay, so I take 0.5 times it by 9.1, exponent -31, times 4 exponent 6 squared divided by 1.6 exponent -19, and I get a potential difference of 45.5. And again, if we were at school right now and doing at the pace we should be going at, we would have done a bunch of stuff on work and energy already, but that has to wait till next week to get that. So this I introduced to you. I asked you to put those two equations, the work equals Q over V, onto this equation sheet. It is on the other equation sheet. All right, and work is equal to to kinetic energy, which is 1/2 mv squared. And it's actually the change in kinetic energy. All right, and then the last one is, what is the frequency in which the electron moves around its circular path? Okay. So this one's a little bit more difficult to do because we haven't done anything with it. And so ideally what we would do is we'd use the radius, find the circumference of the circle. Once we have that distance, we would divide it by the velocity to get the period, and then the period to get the frequency. But we're going to leave that for right now. We won't have that question just yet because we haven't done enough work with frequency and period just yet. Okay? So you can leave C for now. I mean, you could do it by finding your time that it goes around the circle, by finding the circumference of the circle, dividing it by the velocity that's moving at, and then take 1 over that value and you would get your frequency. Okay?
Okay.
All right, other questions from that worksheet? Rory?
No, I'm going to go see Mr. Ross in a couple days here.
Wow, okay. So my thoughts were to give you an assignment today. Should I leave it till Monday? Well, I'll post it today. How about that? And then Monday, I'll make it due for the end of next week. But you can expect to, on Tuesday, to start something new. Fair enough?
Yeah.
Yeah.
Sounds okay. I didn't really think this was that hard.
Okay.